All right, let's take a look at the odd number questions on this worksheet too. So whenever we look at these values, these inverse trig function questions, it's very important that you know what quadrants they are. And if it's a positive, it's very easy. It's always quadrant 1 if it's positive. You should only be more alert when you see a negative number like number 3. So for question number 1, we're asking, hey guys, what is the angle if tangent of that angle gives you √3/3? And we say it must be pi/6. Tangent of pi/6, it's √3/3. So now I would suggest you to verbalize this whole thought process. Talk to yourself. Oh, what angle? Tangent of what angle gives me √3/3? Okay. Now for this one, number 3. Now there are a couple of ways you can think about number 3. You can ask a very simple question. Cosecant of what angle gives me -1? Cosecant of what angle gives me a -1? Well, but first, it's a negative. So what's the restriction? It's a negative, so it must be in quadrant 4. Okay. So you have to know that first, and I would strongly suggest you to write this down. There's no point to hold it in your head. Write it down to remind yourself it's quadrant 4. So then you continue to think, cosecant of what angle will give you -1? And hopefully, in your head, that gives you -pi/2. So that's one way to think about it. If you know your cosecant values very well. If you know your cosecant graph very well, that would work too. Now the other way you can think about this, okay, if you're like me, who dislikes secant and cosecant stuff, so you can do this. You can say, well, can we just change this to arc sine? And in doing so, can I just do the reciprocal of -1, which is -1/1, still -1? Can you do that? We say, yeah, sure. Just make sure you flip the ratio. So then we can ask the question. So also in quadrant 4, sine of what angle gives you -1? Also -pi/2. Also -pi/2. So you can ask the same question in different ways and you will still achieve the same answer. Make sure you can hear your own dialogues in your head. Inverse tangent of -3, you see the negative sign, so you got to think about the quadrant. Everybody, what's the quadrant? Quadrant 4. Okay, so we ask the question, hey, what angle in quadrant 4? The tangent of what angle in quadrant 4 will give you a value of -3? It must be -pi/3. Okay. Number 7. Hey, what's tangent of what angle? We'll give you 0. Tangent of 0 gives you 0. Yeah, this one, I'm like, don't really like this kind of thinking. So for me, I probably would think about arctangent of -3. Okay, so I just do the reciprocal. Okay, so like √3/3 was originally 1/3. So if I go back to tangent, so it's just -3. So I'm asking the question, yeah, so, oh wait, hold on. That actually would not work so well. Well, first, it's a negative, so it's in quadrant 2. Yeah, that may not work so well because it will not give you a quadrant 2 angle. So quadrant 2 with this negative. So what angle? Cotangent of what angle in quadrant 2 will give you negative root 3 over 3? It must be 2 pi over 3. Okay. I would say this one it's a bit challenging because the difference of cotangent and tangent, you cannot think about tangent in this case because the restrictions are different. So like for secant and cosecant, you're more than welcome to flip it back to sine and cosine. But tangent and cotangent, they don't really communicate well with each other. Right now, for the next portion, okay, I'm gonna pick a few to do. For number 11, just do it step by step. Okay, do it step by step. Figure out the inside first, and write out your notation. What's cosine of pi? Cosine pi is -1. So tangent of inverse tangent of -1 is tangent of what angle? Gives you a -1. Negative pi over 4. Okay, again, got to know this is an angle restricted to quadrant 4 with this -1 value. Okay. I'm going to skip to number 15. Now for 15, just do it step by step. Figure out the inside first. And I'll tell you why. All right, so what is sine of 5 pi over 6? Sine of 5 pi over 6 is 1/2. And sine inverse, or inverse sine of 1/2, that will be a quadrant 1 angle. And this will be pi over 6. Now, it's very simple if you follow the thought process, the procedure. Okay, so you finish the stuff inside the parentheses first, and then you do the stuff on the outside. Now, I will put a little asterisk right here just to make you aware of something. Some of you may raise the question, hey, this is sine and inverse sine. Can they just cancel each other? Can they be canceled out? Well, it would be lovely if they can cancel each other out. However, if they do cancel each other out, the answer would be 5 pi over 6, which is going to be a problem because inverse of an angle, inverse of a ratio should give you a value in either quadrants 1 and quadrant 4. The fact that 5 pi over 6 is in quadrant 2 would not be a valid value. So that's why I'm going to urge you, just do it step by step, finish the inside, work on the outside. Don't rush to cancel the stuff out. Okay? And then for the bottom part, just make sure that you know, write out the quadrant. Like for number 21, arc cotangent of -3/4. With this negative, that tells you this angle is in quadrant 2. It's in quadrant 2. And sine of an angle in quadrant 2, well, it's going to be positive, so don't worry. And since it is 3/4, it's not anything nice, so you would actually draw a triangle. And cotangent, it's adjacent over hypotenuse. Adjacent over opposite. So 3/4. Okay, 3, 4, and there should be a number screaming in your head. That's a number 5. 3, 4, 5 triangle. And sine of this little theta thing, this angle, it's going to be 4/5. Okay. And one last one. It's going to be number 25. So inverse tangent of x inside the sine function. So what it's saying, it's it's x/1. All right, so x over 1, you find out that this is 1 plus x squared. And so sine is x over 1 plus x squared square root. You rationalize it. And then you have x square root of 1 plus x squared over 1 plus x squared.